Welcome back to the Math Professors. If you enjoy content that can be found at any college math class, please consider liking, subscribing, and sharing. Professor Van Hamlin. And we're going to cover Gauss-Jordan elimination. And we're going to start with two variables, two equations, just to kind of get the technique down, and I'm going to expand this to three variables and three equations. So what we know is we've already done Gaussian elimination with back substitution, so I know I want to do a 1, a 0 here, and then a 1 here when possible. Now, Gauss-Jordan, what it does is it makes this whole left-hand side really the identity. I want 1, 0, and then 1, 0. And then over here is just going to be left with our solutions. So let me show you what I mean by that. All right, so the first thing I'm going to do is just write this as a matrix. So this is 2, 3, 1, 1, minus 5, minus 6. And then it'd be nice if this was a 1, and the easiest way to make that top of the 1 is just, switch row 1 and row 2. Row 1, switch with row 2. So now this is going to be the matrix 1, minus 5, minus 6, and then 2, 3, 1. All right, so we got a 1 here. Now make this a 0. So since I'm in column 1, I'm going to use row 1 now that that's a 1. So minus 2, row 1 plus row 2 is going to be my new row 2. So let's check what we get here. So we have row 1 is going to be the same. So minus 2 times 1 plus 2 is 0. Minus 2 times 5 is going to be 10, plus 3 is 13. And then minus 2 times 6 is going to be 12, plus 1 is going to be equal to 13. So now what I'm going to do is I want to make this a 1. And since it's both divisible by 13, a really easy way of doing that is just go 1/13 row 2. This is going to be my new row 2. So now we're going to get this matrix. 1, minus 5, 6, and then 0, 1, 1. So that would have been where we go with Gaussian substitution. Then we would just rewrite as a system of equations and then back substitute. But I'm not done yet. I want to now make this a 0 as well. So since I'm in column 2, I'm going to use row 2. So just like here, I was in column 1. So in order to use column 1 to make that 2, I'm going to use row 1. So it's the same kind of idea, since I'm still in column 2, and now I'm going to use row 2. But it's kind of important that we make this, this left-hand triangular matrix 1, 0, 1 first before you start going after this. All right, so now in order to make that a 0, I'm going to go 5 row 2 plus row 1, so I'm going to do row 1. And what we get back here is row 2 is unchanged. And now row 1 is going to be 5 times 0 plus 1 is going to be 1. 5 times 1 minus 5 is going to be 0. 5 times 1, this should be a minus 6. So 5 times 1 is 5, minus 6 is negative 1. All right, so let's rewrite this as a system of equations now. Remember, this says 1x plus 0y is equal to negative 1. This says 0x plus 1y is equal to positive 1. Or, simply this says x equals negative 1 and then y equals positive 1. So really when you write this and when you completely put this in row reduced echelon form, and you'll see this R, R, E, F even on your calculator. If you row reduce, this matrix, let's call this the matrix A, it's going to spit out that thing. And that's really what this is. This is the row reduced echelon form of this particular matrix. And when you do that, these numbers here are simply your solutions to your first variable and then your second variable. All right, let's do this with three variables and three equations. So this is our system of equations, and what I'm going to do is I'm going to put this in matrix form. And I'd forgive you guys if you're doing this at home, is to switch row 1 and row 3 immediately. But we'll do that in due time. Now, what we've done a lot of times is we grab these problems out of books, and when you're doing your homework problems, say you have your book and you put a homework problem up there, you've written this system of equations, horizontally. What I'd really recommend you guys do is just double check your coefficients, make sure that you wrote them down from your book correctly, because boy, if you miss a minus sign or miss a number, you might take something that has really nice solutions and turn it into something that has really horrified or very challenging solutions. So it might take you forever to solve and wonder, like, why was that so difficult? So just double check, and the way I do double check is I just now double check that vertically the coefficients match up with what I'm supposed to have. All right, so now make this a 1, this is 0, this is 0. So this is how we're gonna just process this most every time. So I'm gonna do row 1 switched with row 3. So that's gonna give us a 1 of 5 minus 12 1, and then row 2 is unchanged, and then row 3 is gonna be my row 1. All right, now that we have that, our job is to make this a 0 and this a 0. So now, since I'm in column 1, I'm going to use row 1 to do that. So in order to get a 3, I'm going to have minus 3, row 1 plus row 2 is going to be my new row 2. And I want to get this 2 gone too. So again, I'm still in column 1, so I'm going to use row 1. So minus 2, row 1 plus row 3 is my new row 3. And let's see what we get back here. All right, so row 1 is unchanged. Might as well write that down. All right, so minus 3, this is 0. Perfect. Minus 3 times 5 is minus 15. Plus 9 is going to be minus 6. I should have a calculator out just to make sure I don't mess these things up. Just to double check them. Now, minus 3 times 12 minus 21 gives us minus 57. So afraid of that. Make sure that we're good. Nope, that's a minus 12. Minus 3 times minus 12 minus 21 gives us 15. That's better. Better as far as I was kind of hoping to be. You're just kind of hoping for pretty things. All right, so minus 3 times 1 is minus 3 plus 0 is minus 3. All right, so that's that one. Similarly, I have to do this for this bottom one. Minus 2 times 1 is going to be minus 2 plus 2. Minus 2 times 5 is minus 10, plus 4 is minus 6. Oh, if we get like a 15 and a 3, I chose poorly. Minus 2 times 12, so minus 2 times 12 times minus 12 minus 10 gives us 14. And then minus 2 times 1 is minus 2, minus that is minus 4. All right. Now we're getting close. So now my job is to go ahead and try to make this a 1. Now, unfortunately, we're going to introduce fractions, but that's just the way she goes sometimes. So we don't. Let me kind of explain. We don't actually have to make this a 1 and this a 0. Really what we're trying to do is, the reason why I made this a 1 is because I want these things to eliminate really easily, and in order to make multiples, if I have a 1, it's easy to make a multiple of 3. I just multiply that by negative 3. Same thing here. It's easy to make this a multiple of 2. Just multiply that by negative 2. Now notice that negative 6 and negative 6, these things are already multiples of each other. So I'm gonna change the sign of this. I'm gonna go minus row 2 is gonna be my new row 2, and instead of making that a 1, let's just leave it a 6, because my job really is to make these bottom 3 a 0, and I can make those 1s later. So let's pop it up here. Now what we're gonna have is 1 5 minus 12 1, 0 6 minus 15 minus 3. And then 0, minus 6, 14, minus 4. All right. So now, since these are direct multiples of each other, I can just do row 2 plus row 3 is going to be my new row 3, and that'll turn that thing into a 0. So 1, 0, actually, let's just rewrite row 1, rewrite row 2. So 0, 6, minus 15, minus 3. Now 0, this plus this is 0. This plus this is negative 1. This plus this is negative 7. All right, so that made that pretty nice. Now, we also know we can do, minus row 3 is going to be my new row 3, and that'll turn, those things positive. And we might as well do that. And once we have this, I'll put this down here, we have to talk about what we're going to go about next. Right. We'll go after that 6 eventually, I promise. So now what I want to do is I want to turn, these two numbers into 0. So just like we kind of slid from left to right, now once you have that lower triangular matrix, we're going to go from right to left, and now we're going to take care of these numbers here. And since this is a 1, it's going to be really easy to get rid of those numbers. So I'll write it up here. So to get rid of this minus 12, I'm going to have, I'll have to put it up here, I have 12 row 1 plus row 3. That's not right. Let's try that again. Remember that I'm in column 3, so I have to use a row 3. So 12 row 3 plus row 1 is my new row 1. And then similarly for this minus 15, I am in column 3, so I have to use row 3. So this is going to be 15 row 3 plus row 2 is going to be my new row 2. All right, so let's see what happens. So row 1 is row 3 is unchanged, so I can put that down there. 0, 0, 1, 7. And let's see what we have for row 1. So 12 times this plus this is 1. 12 times this plus this is still 5. That's why we work right to left, because of those zeros there. 12 times this plus this is 0. That's nice. Now, 12 times 7 is going to be 84. Plus 1 is going to be 85. Let's just double check that. 12 times 7 plus 1. Love it. 85. All right. And now, very similarly, I have to take care of that minus 15. So 15 times this plus this is still going to be 0. 15 times 0 plus 6 is still going to be 6. 15 times 1 minus 15 is going to be equal to 0. And then 15 times 7. 15 times 7 minus 3 is going to be equal to 102. All right. So, is 102 divisible by 6? I bet you it is. No, it's divisible by 3 because the sum of the digits are divisible by 3. And it's also even, so yeah, it's definitely divisible by 6. So this is divisible by 6 because 1 plus 0 plus 2 is a multiple of 3, so it's divisible by 3 plus it's even, so it's definitely divisible by 6. And when you divide it by 6, you get 17. So let's go ahead and handle that thing right now. So I can go 1, 6, row 2 is going to be my new row 2, and now we're going to get 1, 5, 0, 85. We're going to get 0, 1, 0, I want to say 17. And then I have 0, 0, 1, 7. Okay. Now, we've taken care of this. We're still working this way for this the upper right-hand part. I need to get rid of this 5. So the way to get rid of a 5 is I have to, I'm in column 2, so I have to use row 2. So minus 5 row 2 plus row 1 is my new row 1. And what do we get? Well, row 2 and row 3 are unchanged, which is nice. I don't know if you've spotted that, but those are the answers for x2 and x3. So now where we are at row 2, minus 5 times 0 plus 1 is 1. Love it. Minus 5 times 1 is minus 5 plus 5 is 0, which was the goal. Minus 5 times this plus this is 0. Awesome. Now, minus 5 times 17 plus 85. Minus 5 times 17 plus 85 gives us 0. 50. Yeah, it sure does. Okay. That's okay. All right. So, what we get here for our solution is, remember that these numbers here represent the solutions to our, first, second, and third variable. That this says x1 plus 0, x2 plus 0, x3 is equal to 0. So it really just says x1 is equal to 0. This says y1 is equal, x2 is equal to 17, and then x3 is equal to 7. And if you want to use x, y, and z instead, again, I've already kind of explained that that is nothing more than a choice on what you want to write. So if you like the content, please subscribe.